In Chapter 2, you learned how to solve equations with whole numbers. Chapter 3, we've been learning fractions and decimals, so let's solve some equations with those rational numbers. That's your target for today. That's what we're going to be working on, so go ahead and take a second to copy that down. While you're copying that down, you may be looking at these pictures thinking, what is this? You're going to see that example 2 is about this giant diamond that they found, and it's the largest piece of the Cullinan diamond, and they cut it into a whole bunch of still giant diamonds. So our second word problem that we're going to use equations to solve deals with this diamond. I just thought I would show you a picture of it. And the picture is taken from about 1908, which is pretty cool. And King Edward VII is pretty lucky because his 66th birthday, he got one of these diamonds. I'd like one of them too. So copy on your target, and then we'll get started. For the first two examples, I don't think you really need to watch me solve these, so go ahead and just solve it along with me. You're solving an equation, and when you solve an equation, you know what to do. Isolate the variable, get it by itself. So undo whatever's being done to that variable. The only difference with what you're doing in this chapter, this section, from what you've done previously, is that you didn't have decimals, and now you do. So we're undoing order of operations. To get n by itself, we would subtract 4.7 from both sides, or minus 4 7/10. And now when you do this side, you just have to remember your rules. Here we have a negative and a negative. Subtracting is the same as adding a negative. So we're adding the same sign, add the numbers, keep the sign. Negative 4.7, negative 4.7, my answer's going to be negative. Now add them. So remember, line up those decimals and add them up. You won't have a calculator for this, so you need to make sure you keep that lined up and do it correctly. This first equation, get n to be negative 9 and 4/10. You can always show a check step if you'd like. You can plug in that negative 9 and 4/10 into the equation and check it and see if it works. If I add a negative 9.4 plus a 4.7, adding opposite signs or different signs, find the difference and keep the sign of the larger digit. So we would subtract, again, line up that decimal, and our answer would be negative because the larger number is negative. This equation does equal negative 4.7. Okay, so you can show a check step by plugging it back in. Try the second equation too. Get n by itself, undo what's being done. So in this first one here, we would either have to multiply by 2.8 or add 4.9. Which one do you do first? You're undoing PEMDAS. Please excuse my dear Aunt Sally. So undo the addition and subtraction first. Work backwards. So we would add to both sides. Line up that decimal when you do this. Again, adding same signs or different signs, you're actually going to find the difference. You may want to do this off to the side, do the larger minus the smaller digit, keep the sign of the larger. So I already know my answer here is going to be negative, and now I'm just doing the subtraction because we're subtracting. Now what do you do to get n by itself? Well, it's being divided by 2.8, so let's multiply by 2.8. Multiplying cancels out that dividing on the left. And now we multiply our decimals. Remember, for multiplying decimals, you don't have to line it up, you just have to multiply it first. 8 times 2 is 16, carry the 1. 8 times 2 is 16 plus that 1 is 7. And the 1, put the placeholder 0 in there because now we're really multiplying by like a whole number. So 2 times 2 is 4, and 2 times 2 is 4, and add these together here. How do I know where my decimal goes? 1, 2, 1, 2. And the last thing, don't forget the sign. A negative times a positive, you know your answer is going to be negative. So you have a lot to remember there. These equations just got harder because you have to remember Okay, your sign rules, is it going to be a positive or a negative? You have to remember to move that decimal over in the end. Don't forget all these steps. You've learned them before, but now you're putting it all together. So you should feel pretty comfortable with solving equations. You're going to practice this some more, but I wanted to give you a word problem to try it on next, okay? These two are a little more challenging. This is actually an earth science example from your textbook. So the largest of all known diamonds is the Cullinan diamond, and it weighed 3,106 carats before it was cut into 105 gems, all from one diamond. That's pretty cool. The largest cut, the Cullinan 1, or the Great Star of Africa as they call it, weighs 530 and 1/5 carats. Another Cullinan 2 weighs 317 and 2/5 carats, and Cullinan 3 weighs 94 and 2/5 carats. And Cullinan 4 weighs 63 and 3/5 carats. So it made even more diamonds. These are just the biggest that they got out of it. I have two questions for you. Which diamond weighs 223 carats less than the Cullinan 2? And how many carats of the original Cullinan diamond were left after the Great Star of Africa and the Cullinan 2 were cut? So if you want to pause and try these on your own, you can do that, and then press play to see how I did it. We'll compare our answers. So try these two now. If you're a little stuck, I'll help you out here. We're saying 223 less than the Cullinan 2. So it may help you to start with an equation. Think about how you would write less than. If it's 10 less than something, you put that something minus the less than part. So you're going to be figuring out the Cullinan 2, taking away the 223. That's going to be the equation you start with for A. And for B, some key information that might help you set up your equation. We want to know what was left after the Great Star and the Cullinan were cut. So that means from the whole thing, from the total. So I kind of think about equations as words first, before the numbers, before filling in. And it helps me to think about this. The star, the Great Star, plus the Cullinan 2, plus whatever's left over is going to equal that total amount. And that original diamond was 3,106 carats. So these two might help you. Pause now if you still haven't solved it. I want you to try it on your own. Alright, so hopefully you have an answer for both of these equations. Your equation may look a little different than mine, or your work may look a little different than mine. But we should have the same answer. Here in this first one, we take the Cullinan 2 and we subtract the 223. When we're subtracting, we get 94 and 2/5 carats, but what did it ask for? It said, which diamond is this? So my answer is actually the Cullinan 3. For B, I know the Great Star and I know the Cullinan 2. I want to know what's left after those two from the total. So what I did is I added the two amounts that I knew, and I got 847 and 3/5. Plus the leftovers is going to give me that total amount of carats that I had from the start. To get x by itself then, I subtracted 847 and 3/5 from both sides. And this is kind of a little trick over here. I could have made this an improper fraction, but it would have been huge. I didn't want to deal with that. So I took 3,106 and I made it 3,105, and I took the 1 that I took off of there and put it as a fraction. 1 is the same as 5/5, and I chose 5/5 because now I can add or subtract these parts really together. So this number right here is the same as this number right here, it just looks a little different, right? Now when I subtract, I can subtract these parts, and I can subtract the wholes, and I get 253 and 2/5 carats as my leftovers. So you're going to do the quick check on showing me that you know how to solve equations with rational numbers. You'll be on to your project.